Today we'll see trigonometric ratios of 0 degree and 90 degree. First, we'll take angle 0 degree. For that, we need to take a right angle triangle. See here, angle A, I will call it as theta. Now in this triangle, what I will do, I will try to reduce theta and then see what happens with BC. This is the original triangle and here I have reduced A, that means angle theta. As I have reduced angle theta, look at this side BC. BC also what? Reduced, right? Now observe this angle theta and side opposite side, correct? So that what happens with this one? Keep on observing. See, in the next triangle, this is the original triangle. And once again, here I reduced this angle theta. As I reduced this theta, once again, BC became smaller than the previous one. Exactly the same way, I will keep on reducing theta and it will just approach 0. It will not become exactly 0, but it will approach 0. As it will approach 0, this BC will become very, very small. That means BC, this length will become the negligible length, right? It means that when this theta will approach 0, then this AC will fall on AB, right? So AC and AB will be almost equal. See here, look at this. This is the original triangle and this theta is now approaching to 0 degree. That means it is almost 0 degree. That's the reason this BC became very, very small, which we are not able to see here. Correct? So have you observed? Here this theta is the bigger one. This side is the longer one. Theta became little small. This side became little smaller. Once again, we made it small. This side also became very small. And at this place, theta is approaching to 0. That's the reason this BC also became very, very small, which we are not able to measure also. That means it is almost 0. So theta is almost 0. That's the reason this length of BC also became almost 0. Now for the first triangle, we'll write down the ratio. See, sine theta, which is equal to opposite side by the hypotenuse. If you see here, this is the opposite side, this is the hypotenuse. Same will go for the second triangle, same for the third triangle. Now observe the fourth triangle. Here theta becomes 0. Approximately 0 means what? Almost 0. So here sine 0 degree. So length of BC is not measurable. It is negligible. So what we are saying? BC became 0. AC as it is. So 0 by anything will become what? 0 only. So finally we get sine 0 degree, which is equal to 0. Correct? Now remember this one. Sine 0 degree, which is equal to 0. Now we'll write down the another ratio for cos. See here, cos theta, which is equal to adjacent side by the hypotenuse. This one, adjacent side by hypotenuse. Same goes for the second triangle. Same goes for the third triangle. Now for the fourth triangle, you see here, this adjacent side and the hypotenuse, they are almost overlapping. That means they are same. Correct? So here I'll write down cos 0 degree because our theta is 0. Cos 0 degree, which is equal to AB by AB I have written. Why? Because AC and AB are equal. AC is falling on AB. Therefore, both these sides are equal. Easily we can cancel them. And then finally we get the answer cos 0 degree, which is equal to 1. Correct? So for 0 degree angle, we have got the ratio for sine 0 degree and ratio for cos 0 degree. So remember these two ratios, which are very important. Now we'll see angle 90 degree. For that also, once again, we'll take the right angle triangle here. Now what I will do, in the previous one, I reduced this angle theta. Now I will increase this angle theta. Correct? And then we'll see what happens. See here, original triangle. Now this theta is approaching towards B, angle B, which is 90 degree. So as this theta is approaching towards this angle B, this length AB is getting reduced, correct? So theta is getting increased, but this length is getting reduced. Now see here, this one became the smaller than the previous one. See the next one, this is the original triangle. Once again, I will increase theta. See, theta is approaching towards angle B, and once again AB got reduced. Finally, what will happen? As theta will approach this angle B, this theta will become 90 degree, but this AB will become invisible. AB will not present. The length we will not able to measure. It is negligible, right? See here, what happens? Original triangle, and this A point comes here on B, right? They are overlapping here at this place. And this our angle A, that means that theta became 90 degree, but AB, this length is not visible now. It became almost 0, correct? Now for the first triangle, we'll write down the sine. Sine theta, which is equal to BC by AC, opposite by hypotenuse. Same for the second triangle, same for the third triangle. Now observe the fourth triangle. Now our theta became 90 degree at this place. As it became 90 degree, opposite side BC is present, no doubt. And hypotenuse, which was AC, right? But this AC is now overlapping on what? BC, correct? It is falling on BC here. So this BC, instead of AC, what I have written here? BC I have written. See, here it was AC. So instead of AC, I replaced with BC. Now BC and BC are same, we can cancel easily. And finally we get sine 90 degree, which is equal to 1, right? Now we'll go for the another ratio. See, cos theta, which is equal to adjacent side by the hypotenuse here, AB by AC. Same goes for the second one, third one. Now look at the fourth one here. Here fourth one, this adjacent side, which was here AB, now this AB, it's not present here. AB, it almost became 0. So instead of AB, I have written here 0, and 0 by anything is what? 0 only. So here our cos 90 degree, which is equal to 0. See, sine 90 degree became 1 and cos 90 degree became 0. So this way we get these two ratios. Now these are also very important. Now from these ratios only, we are going to derive other ratios. Just see this one. Trigonometric ratios for 0 degree. Sine 0 degree, you know it, 0. Cos 0 degree is 1. Tan 0 degree, which is equal to what? Sine 0 degree by cos 0 degree. And you know the value of sine. 0 is 0 and cos 0 degree is 1. 0 by 1, which is 0. So tan 0 degree comes as 0. See the cosec? Cosec 0 degree, which is equal to 1 by sine 0 degree, right? Which is equal to 1 by 0, because sine 0 is 0. So 1 by 0, it means that not defined. See the sec 0? Sec 0 degree, which is equal to 1 by cos 0 degree, which is equal to 1 by 1, which is equal to 1, right? Now the cot 0 degree. Cot means cos by sine. So cos 0 is 1 and sine 0 degree is 0. So 1 by 0 is not defined. It means that if you know sine 0 degree and cos 0 degree, rest all ratios you are able to find out. Correct? Now let us see the trigonometric ratios of angle 90 degree. Sine 90 degree is 1. Cos 90 degree is 0. Now from here only, we'll write down tan 90 degree, which is equal to sine 90 degree by cos 90 degree, which is equal to 1 by 0, which is equal to not defined. Correct? Now here, cosec 90 degree, which is equal to 1 by sine 90 degree, which is equal to 1 by 1, which comes as 1. See, sec 90 degree, which is equal to 1 by cos 90 degree. Cos 90 degree is 0. So 1 by 0 here, which is equal to not defined. Cot 90 degree is cos by sine. So cos 90 is 0 and sine 90 is 1. So 0 by 1, which is equal to 0. Now try this. Write down the following ratios. First one, sine 0 degree, cosec 90 degree, cos 90 degree, cot 0 degree, sine 90 degree, cos 0 degree, tan 90 degree, and sec 0 degree. I hope all of you have written the correct ratios.